Okay, well, after reviewing this little topic in normal probability, let's go back and review what the meaning of conditional probability is. Well, let's look at the experiment. Let's use a concrete example of defining it in terms of, say, the probability experiment of 2 coin tosses. So you know that the sample space size is going to be well. Let me see. Maybe we need to make this enough to make this. Well, no. Let's try 2 coin tosses. We may not get all the possibilities, but that'll be enough. So the sample space here is going to equal, using heads H and T for the different outcomes on the first and second toss of the coin. Here's the sample space. So the size of the sample space equals 4. Now we can consider various, we want conditional probability. It has to do with connections between different events. And we're going to see that there's two big sort of categories of independent and dependent events. But first we have, and to understand this difference, we have to understand what conditional probability is. So the idea then is that we're going to have, we want to know what's the probability that event A occurs, given that a second event has occurred. Now, what's the definition of this? Well, our definition is going to be the probability that both events occur divided by the probability that the second event occurs. So in other words, this we tried to motivate this on Friday in terms of counting. It's like, if you know that B has occurred, B is sort of like the new sample space. So this is equal to the number of, each of these probabilities has the size of the sample space divided by 4. So if I multiply numerator and denominator by 4, I'm just going to get this counting thing here. And this sort of looks like a probability in which I've changed the sample space size from the whole space to this event B. And then I'm looking at only the events that I'm looking for A, but only those events A, those outcomes in A that also occurred in B. So we try to make this plausible, and this is sort of the official definition that applies even when this classical probability stuff doesn't apply. But let's see how this, let's try to define 2 events and see how this works out in practice. Well, we need 2 events. So let's have, let's let event A be at least one head occurs. Now, let's say this is the probability that 2 heads occur, and B be the event that at least one, oh, I don't need capitalization here. A is the event that 2 heads occur. B is the event that at least one head occurs. Well, let's apply the definition and see how that works out. So the probability that A occurs given that B occurs is going to be, well, we can do it 2 ways. We can either do this counting or look at the probability. Let's look at the probability first, just directly, then we'll see that it also works here. The probability that both occur. What's the intersection of the event that 2 heads occur and at least one heads occur? Well, that's this event here is H H, H, T, TH. This event is just H. H. Okay, it's just this one outcome HH. Well, the intersection of these two is just A. So this equals the probability that A intersection B over B, but the intersection of A and B is just A. Well, if the probability of A that two heads occurs, you can see this is only 1 out of 4. So if we just did the counting, this would be 1/4. And if the probability of B that at least one head occurs would be 3/4. And you can see this is sort of like 1/4 in the numerator. This is 3 times 1/4 in the denominator. So the answer here is going to be 1/3. Okay. Now, if I just didn't do the probabilities directly, but just went and looked at this number here would be, let's say, starting again the same way, but using this processed form. Well, this would be 1 and this would be 3. So this is like the idea of a reduced sample space, and they agree. So the idea here is, you see, that because we know that B occurred, it's sort of like we know our new sample space size is this, because we know that this can't occur. So we're asking, in this new sample space size that's given by this denominator, what's the probability this occurs? So there's the 1 in 3, this 1 in 3 probability. So that's the sort of the definition or idea of conditional probability and how it works out with its definition. So in this context, now let's try to look and understand what independent and dependent events are.